Hello, it's a guy Olumide, and today I'm gonna be talking about another one of the most commonly asked tech interview question, and the title of the problem is zero stripping. The problem statement says, for each zero in an m by n matrix, set its entire row and column to zero in place. We see that this question is straightforward. It just wants us to set the entire row and column of any cell that whose value is 0. It wants us to set it to 0 in place, meaning that we must set it in place and not just create a new board or a new data structure. So we need to, this existing one, we need to do it in place. So, and look at this for instance now. So this one contains 0, this particular cell also contains 0, and because of that, all the old rows here are set to 0. So, and including all the old columns here. And similarly, because here is 0, all the old rows here are also set to 0, and all the old columns here are also set to 0. This is simply what the question and the problem statement is asking us to do, and it wants us to do it in place. Yeah, a quick one. Engaging tech content like this boosts your visibility to recruiters, hiring manager, and even employees working at various tech companies that you dream of working to as well. So engaging by liking, commenting, and sharing of this video and any other tech content will increase your visibility. You don't know who is watching, so do well to share, to comment, and engage as much as you can. It's gonna help you. It's gonna help me too by promoting my content. So thank you very much. A key observation is that if a row or column contains a 0, all the cells in that row or column will eventually be replaced by 0, just like in this case that this is a 0 and every cell in that particular row and in this particular column becomes 0. So by observing that, we can see that there is no need to preserve any value in that particular row column, meaning that the fact that everything here is going to be 0 eventually, and everything here as well is going to be 0 because this cell contains 0. So there's no need to preserve. We don't actually need any of this number as far as there is a 0 here. All of them are still going to be converted to 0 in place. By this, a strategy that we can try to use is that we should use the first row, this first row here, and the first column, which is here, this first column here and this first row. We should use them as trackers in order to track which row and which column contain a 0. Let's consider an example to explain this further. Here you can see that we use the first column to mark the row that contains a 0. Look at this row, it contains a 0, and what we do is that over here we use the first column to represent that, okay, as a marker that this row contains a 0. Don't forget this is the first column now, so we are using it to represent that this row contains a 0. Well, anyways, we do not need the elements at this place. We don't need to preserve or reserve it. Why? Because everything is going to turn to 0 in this particular row. So we just try to use the first the corresponding cell on the first column, so to be as a marker that the entire row is going to be 0. So the strategy we are trying to use is just that. So if any cell in this row or in any other row, take for instance this as well, because this particular cell is 0, what we do is that we come and set the corresponding cell at this column. You understand? So the corresponding cell at this column, we set it to 0 to signify that, okay, there is a 0 in this particular row. So anytime we just brush through this particular column now, the first column, anytime we see a 0, we know that every row in that column should become 0. So Similarly to how we mark rows, we can also mark column containing 0 using the first row. So in a situation whereby we have a cell that contains 0, we've concluded that we are going to mark the corresponding cell at the first column here. This is the first column now, so we are going to mark it to 0 to signify that the entire cell in that row should be set to 0 in this particular row, and that's what we did here, where we set it to 0 over here. So, and also similarly, because the question asks us to strip the entire row and column of that particular cell to 0, we can do the same for the column now by placing the corresponding row. This is the first row here. So this is the first row here. So placing the corresponding row of that particular cell that has a value of 0, placing it to 0 to signify that every column here will become 0. So just like we did vertically for this, we are doing now horizontally for this. And don't forget that working vertically with this one up here, we cause the column, a single column, you understand, is where we are using as the marker, and working here also we are using a single row. So by implication, anytime we see a 0, the corresponding cell at the first row is where we are going to set to 0. Look at it, is the first row right here, you understand. So and the corresponding cell is the cell that align with this particular cell with value 0. So we are going to set it to 0 as well. So that's the two strategy that if you see now, you will observe that we are actually using the first row and the first column as pointers. Here now, this is the first column, we are using that as a pointer, and we are using also the first row right here as a pointer right here. So that's the strategy we're going to be using. Now, to set this marker, just like we explained logically now, to set this marker for the first row and column, we begin by actually searching from the second row and second column. What I mean by that is that we begin by searching from this particular here. Don't forget that we are using this entire first row and first column as marker. So we are going to start our search from here and here to here to here to here to the rest of the array till it gets here. So we are starting from the second row and second column. So and anytime you see that the value evaluates 0, we will set its corresponding cell at the first column to 0 and corresponding cell at the second column to 0. So that's how we're going to be setting our marker, starting from the second row, second column, trying to check if it is the 0. If it is, set the corresponding row at the first column to 0 as a marker, corresponding at the second column as a marker to 0 as a marker, and then you move on to the next element, and we try to check through all the next elements like that. So following the logic we described, we are now going to start from the second row and second column, and we are going to navigate through the rest of the array. And what we are going to be doing is that we are going to be looking at the pointers, the markers here and here at the first row and at the first column. So starting from this array here that you are seeing here, we are going to look at the corresponding cell at the first row and first column, and if it is 0, we set it to 0, and you see that it becomes 0 at this point here, So then we move on to the next one. So and we try to check, because the corresponding cell at the first column is 0, it will be set to 0. Same thing applies to this, same thing applies to this, because the corresponding cell here is 0. Then we navigate to this one. So don't forget, we are trying to traverse through all the remaining part of the array aside from the first row and the first column, because we are using those ones as markers. So coming here now, fine, it does not have the corresponding cell at the first column to be 0, but we do have the corresponding cell at the first row to be 0, so we set it to 0. Coming here, it does not have both the first here and the first here to be 0, so we leave it. Same thing apply here. So it does not have the corresponding row here to be 0, neither does it have here to be 0, so we leave it. And what it implies is that there's no row across, there's no 0 across the row, as you can see, and across the column, as you can see. But coming here now, this one have a 0, so along the row, along the at the first row. So and what it means is that there's a row somewhere here, there's a 0 somewhere here. So that's what it means, and this is the 0 that we are trying to talk about here. So, and that's why we set this marker to be 0 at this top here, and because of that, every element here, including 15, will become 0, and that's how we just transverse it. Similarly, there's a 0 here. This same 0, we set the marker here, and everything that is here becomes 0. So that's just simply what we are doing. But an important issue that we have not addressed yet is a situation or a case whereby the first row initially contains a 0. Don't forget, we actually we have set the first row and the first column as untouchable. We actually transverse through the second row and second column, which is the submatrix, the remaining of the matrix. So there is no way we have not considered a situation whereby there is actually a 0 at the first row and at the second column. So let's consider that fact now. In a situation like that, you know that the rule will also apply here. Everything here is out to become 0, and everything here out to become 0. But because we've not considered it, if we follow that logic alone, it is not complete. So what do we do? So in a situation like that, what we are going to do is that before we start transversing the sub arrays, first to check if it is a 0 and to set the first pointer and the corresponding indices at the row and column. Before we do that, we are first going to check through the first row here and the first column here if they initially has a 0, and we are going to set it to true. If they do, we are going to set a variable like this: first row has 0, we set it to true. First column has 0, we set it to false. Why? Because the first column does not contain a 0, but the first row do contain a 0 right from time. So, and we are going to do that. After doing that, we will proceed with the logic we described earlier of trying to check through the subarray to find the 0 and setting their corresponding row and column markers to 0. And then after doing that, which is what we did here, you see, first of all, we collect the variables first row as 0 and first column as 0. After doing that, we carry on with the remaining logic we explained earlier, and that's why we have all of this as 0, 0, 0, 0, 0, 0. You understand? Using the logic we explained. And then eventually we are gonna check if first row has 0. If we do, we set all the first row to 0. You see that simple logic over there? And we try to check if first column has 0. If it has, we set everything here to 0. So that way, don't forget that we have collected this value up front. So all this 0 that is at the first column here actually does not belong initially to the first column. Why? Because initially the first column as 0 is false, meaning that at first, look at it here, there is no 0 at all. So all the 0 that is here now is as a result of it being a marker. So that simple logic is that you collect it as a variable, a true or false, if we do have, and because this one do have right from time, so we set the whole row to 0. After doing the whole logic we explained here, we now set it to 0, but because this does not have, we leave it there. So you see that simple logic there. It's just as simple as that. So all right, we are going to be going to the code implementation, and I want you to follow me along with it. All right, let's go into the code implementation for the 0 stripping DSA or Leetcode problem. So we are going to call the function 0 stripping, and we're going to take in the matrix, which is the list of integer. Why? Because it's a list that contains lists, matrix, and then it's going to be returning that same list of integer, but now modified. It's going to be modified now. So one thing I take as an habit is to write down the data. So first place down the data that is being needed. So, and that's what we did here. So let's try some use cases and catch some use cases. So if not matrix, in case if the matrix is just empty, or not matrix of 0. That is, if the first item of the matrix is first column in the matrix is empty, so we can just return our matrix. No need of stressing yourself. So it's just something we catch that exception there. So otherwise, let's take our m and n and define it as the length of our matrix, which represents the number of rows. That is m, length of matrix. So the number of rows 1, 2, 3 in this example. Yn will be the length of a matrix of 0, which means the number of columns. Like now, look at here, matrix, this is matrix of 0 now, so the length represents the number of columns. So doing that now, we are going to be defining, having done that, we're going to be defining alright, having done that, we're going to be defining whether our first row has 0. So first row has 0, so we set it to false initially, and now we are going to iterate through each column in the first row. So iteration through each column in the first row, we are going to check if it is a 0. So if we can find the 0, and if we can, we are going to set the first row as 0 is false by default. Now we're going to set it to true if we can find a 0 in any of the columns of the first row. So, and once we can find it, no need of searching any further, just break out of the loop. So similarly now, we are going to define the first column as 0 for the same purpose of trying to check if the first column, or if each row of the first column have a 0 value. So we're going to set it to false by default, and now we're going to iterate through it for m in range of, let's call it r, so that we can know that we are iterating through each row of the first column. So, and what we're going to do is that we're going to check if it is a 0, if any of them is a 0. So by saying if matrix of r 0 is equals to a 0, so what we're going to do is that we're going to set the first column has 0, we're going to set it to true, and after setting to true, we just need to break out of the loop. So now we've defined these two parameters. Now let's go on with the logic of iterating through the second row and the second column and trying to check if it is a 0. If it is, we are going to set the markers of the first row and the first column, just like we explained in the logic. So and now we're going to iterate through for r in range of 1, m, for c in range of 1, n. So we're going to check if r and c, or if the cell at this position, which is represented by matrix of r and c, if it's a 0, then we want to set a marker at the corresponding cell at the first row and corresponding cell at the first column. So, and this is how we're going to do it. So we are going to set let's set the corresponding cell at the first column first. So, and now you can do that is like this. So we're gonna set it to 0, and similarly let's now set the corresponding cell at the first row. We're gonna set it to 0 as well. So just like we explained in the logic. So now, having set the marker course, this way is gonna go right from the first and the second row, second column is going to go up to the end. That's how we are iterating through. You understand? It's gonna go up to the end, and after that, the next step after setting the markers is to iterate through this same submatrix again, starting from the second row, second column. So to try to set this value to 0 if their corresponding marker at the first row and first column is 0. So let's do that now. For r in range of 1, m, which signifies that start from the first end. Alright, so here we try to check if the marker at the first row is 0, or the marker at the first column. This represents the first column here. If the marker at the first column is 0, if the marker at the first row is 0, we want to set this particular cell value to 0. And I set it to 0. So that's it. We've iterated through the sub matrix first to set the markers, and then we iterate through it again to set them to 0 if their markers are 0. So what we have next now is that issue that we talked about in the logic, and right now we'll be addressing it, that if the first row has 0, then what we want to do is that we want to set every element or every cell in that first row, we want to set it to 0. So if first row has 0, we are gonna set for each column in that first row we are gonna set it to 0. So for the first row, that's why we are placing 0 here, and then for each of their C, I'm gonna set it to 0. So that is if the first row has 0 initially. So similarly, if first column has 0, what we're gonna do is that we're gonna see for C in, now it will be R, because we are going to iterate through each row in that first column in range of 1, m. So we are going to set the matrix of R of 0. I'm going to set it to 0, and that's just it. Then we can return our matrix having done all of this, and we can print and call the function 0 stripping of matrix. So let's just look and glance through it again. Fine, let's run the code. Alright guys, when I run the code, it doesn't give me the desired output, it returns this instead. So, and when I look through, I realize that we make a slight mistake. So here I intend to write C, not 1. So when we iterate through the array at first to set the markers, we are setting the markers at that corresponding at a corresponding cell in the first row and first column. So not 1, it's not a constant 1, it's supposed to be C. Also, we made a slight mistake here, so it's supposed to be R. So we are trying to check if the marker at the first column is 0, so and the marker at the first row is 0, so it's not supposed to be C here, it's supposed to be R, while here remains C. Now let's run our code again. Here now we see we have the correct value returned, which is this. So that's just it. Alright, let's talk about the code implementation in JavaScript now. We have the 0 stripping function, And what we do is just similar to what we did in Python. We try to check if the matrix is an empty matrix, or if the column in the matrix is empty. In that case, we don't need to worry much, we just have to return that matrix as empty. So but if it is not, we define the row and columns, the length of the rows and columns by m and n, where m represents the length of the row, while n represents length of the columns. So and now what we do is that we define the first row as 0, which will help us to check through each column in the first row to see if anyone is a 0, and if it is, it's gonna set it to true. Don't forget it is false by default. So but if you find it, it's gonna set it into true and break out of the loop. So we also define the first column as 0, that is gonna iterate through each row in the column. Don't forget we're dealing with the first column here, first column as 0, so it's gonna iterate through each row in the first column. So and it's gonna check if any of the row has a value of 0, and if we do have, it's gonna set the first column as 0 to true and break out of the loop. So after that, it's then gonna iterate through the first, starting from the second row and second column. So it's gonna check if any of these values are 0. So it's iterating through each cell, starting from the second row and second column. If it is a 0, what it does is that it sets the corresponding cell at the first column and the corresponding cell at the first row to 0, to set as markers that every cell in that row and every cell in that column should be shifted to 0. And here is where we are going to implement that, where we iterate through that same thing again and try to check and look at the corresponding cell at the first column and at the second column of each of the cells, starting from the second row and second column. So and if this corresponding cell, just like we have it here, if the corresponding cell at the first row and the corresponding cell at the first column, if it is a 0, then definitely we are going to set this particular matrix to a 0, or that particular cell that we are, the current cell, to a 0. So after doing that, now we need to check if 0 initially existed in the first row or in the first column. So and that's what we try to check. If it is a true, definitely it existed, and we want to set the whole of the first row to 0, and that's what we did here. We check through each column in the first row and we set each of these columns to 0, so meaning that the first row is set to 0. And we try to do the same for first column. Now if it's evaluated true, definitely there's a 0 in that first column, so we check through each row in that first column and we set each of them to a 0. So and we return the matrix. So it's definitely gonna give us the answer, which is same here. So thank you for listening to this. Don't forget to subscribe, please subscribe, like, comment. Thank you.